All right, get out your vocabulary sheet on continental drift and plate tectonics, and let's go over all our vocabulary and make sure we understand it. Let's start with continental drift. The theory of continental drift said at one time the continents were joined together they broke apart and drifted away from each other. It's much like it says, continental drift, continent and drifting, so continents moving. An easy way to illustrate this would be to show the continents in more of a Pangea formation, and then the same continents drifted apart from each other. And you can illustrate that by, here is my continent, and here is it drifted apart. This one's attached still, and this one has drifted apart. And finally, this one is attached, and it drifted apart. And let's add one more over here. And our continent was here, and it drifted. So that's showing that this is where they once were, all joined, and then they slowly over time drifted apart. The idea of Pangea was first expressed by Alfred Wegener. It's the idea that all continents at one time, about 300 million years ago, were joined together as one large, we know it's going to be really big, gigantic landmass. Okay, so what they're saying is at one time our world had North America, Eurasia, Africa, South America, Antarctica, all joined together in one large landmass. And that landmass was called Pangea. Okay, that's just its name. Alfred Wegener could have named it Bob or Susie or anything else. He just chose to name it Pangea. And that's just its name. And again, it means that all the continents at one time were joined together. And then continental drift said they drifted apart. All right, seafloor spreading. Seafloor spreading is a really important concept to understand. It means that the ocean crust, that's the lithospheric plate, moves slowly apart. Okay, it spreads as molten rock. We know that molten rock is melted. It's magma comes to the surface from the mantle. So what we really have is we have some some oceanic crust and some more oceanic crust. We have our ocean. Okay. Then what we have is we have our mantle way down here. And we know in our mantle there's always magma, and it's flowing around. It's that hot molten rock, and it's always flowing. So as it flows up toward the lithosphere, what happens is it squeezes out right here, and it spreads the oceanic crust. So a good example would be if I had some oceanic crust and I had some magma that came in. The only way that magma can come in is if this spreads apart. Okay, then I have some more magma come in. and it's trying to get in that oceanic ridge. The only way it can get in that oceanic crust is, again, that's got to spread apart. Then I have a little more magma and it's oozing up. Again, the only way it can fit in is if that current oceanic crust spreads apart and lets it come in. Okay, that's a continual process. As molten lava rises from the mantle, it comes up here, it cools, it becomes crust, and then the next time more comes up, it spreads. So it's spreading to let that molten rock come up and create new crust. All right, convection currents. This is a really important idea. We already know a little bit about it, but you probably don't realize you know about it. What that means is things rise, matter, and fall. So it's the rising and falling of matter due to changes in temperature and density. So we know if things are more dense, they're going to sink, and if they're less dense, they're going to fall. So we've got some hot magma here on our mantle. Okay, so we're in our mantle. And it's going to rise because it's hot and it's less dense. But we also know as it comes closer to the lithosphere, it's going to start cooling, because the farther we go down, the hotter it gets. The farther we go up, the cooler it gets. So it's going to start cooling when it gets up here. But we know when it's cool, it's going to be more dense. And as it gets more dense, it's going to fall back into the mantle, and it's going to get hot again. Okay. As it gets hot again, it's going to rise, and then it gets cool and it falls. That is convection currents. Okay? It's constantly moving in the mantle or the asthenosphere, and the lithospheric plates are floating on that. This is a good example in our classroom would be our lava lamp. Okay? As the lava in the lamp gets hot, it rises to the top. When it gets to the top, it cools down and it falls. And that's really what makes a lava lamp work. All right, an earthquake is a tremor or shaking of Earth's crust. Okay, you're probably pretty familiar with an earthquake. So what happens is you've got a tectonic plate, and you've got another tectonic plate. Okay, and remember, this is the boundary where they meet. And as they slide past each other, they're going to create some friction here, which is going to cause an earthquake. If you think about if you have two cookies, okay, and you rub those cookies really hard against each other, they're going to start crumbling. That's the same thing. If the plates rub against each other like that, they're going to create an earthquake, and it's going to send out those tremors or seismic waves all over the place. That's an earthquake. All right, we're going to move over to our other side. And before we talk about the boundaries, I really want to go down here and touch on plate tectonics first. So the theory of tectonic plates is that the lithosphere is broken up into plates or pieces of crust. So, in essence, what it's saying is we have our Earth, okay, and it is made up of all these different plates. or kind of like puzzle pieces. There's some big plates and there's some little plates, but all these plates together make up our Earth. Okay, so we can have maybe the Eurasian plate, we might have the Antarctic plate, up here might be the North American plate. So all these plates or pieces of the lithosphere are put together to make our whole crust. Okay, so we need to know about these plates or pieces to be able to understand the boundaries up above. So at our convergent boundary, it's where two plates, so down here maybe this plate and this plate. Do you see they have a boundary right here where they touch? Okay, it's where two plates collide or crash. Okay, against each other. So this plate and this plate would be colliding. They're coming together and crashing. So basically what that would look like is one plate moving this way, and this plate is moving this way, and at this boundary right here, they're going to collide. They're going to bang. They're going to crash into each other. We're going to talk more about the different types of convergent boundary, but I'm going to give you a little preview. You can have oceanic crust that crashes into oceanic crust. You can have oceanic crust that crashes into continental crust. And you can have continental crust that crashes into other continental crust. We're going to talk more about what happens at these specific boundaries, but all of these are convergent boundaries. Okay? Our next boundary is called a divergent boundary. Again, maybe it's the boundary right here where these meet. Okay? What happens is two plates move away from each other. Okay? Another way to say it is they separate. Thus, the term seafloor spreading, they spread or separate apart. Okay, they spread. All right, so what this would look like is we've got our plate, we've got another plate, and they're moving away from each other. You can see this is moving away and that's moving this way. And what they end up creating right here is called a mid-ocean ridge. Because remember, we've got that hot molten rock oozing up to make this separate. That only happens, that seafloor spreading only happens at a divergent boundary. All right, then we have our transform boundary, and that's where two plates slide past each other. What that creates, we've got one going this way, got one going this way, and we just talked about it. What it creates is your earthquake. It's going to create that seismic waves and the tremors, and it's going to create an earthquake. So these boundaries could happen anywhere. So let's say this boundary is right here where these two meet. Okay. We might have this boundary where this boundary meets this one. Okay, and it could be that our transform boundary might be right here. These can be anywhere. Okay? They're all over. And they react different ways depending on how they come together. And our final vocabulary word is something you're very familiar with. It's an area of Earth where gases and molten rock escape the Earth. Okay, so over time, at a convergent boundary, a volcano has been formed, and in that volcano, coming from the mantle, is hot molten rock. So sometimes it gets so hot that it boils over and it becomes lava, but not always. Sometimes it just continues to gurgle down in here forever in a dormant state. All right, those are our vocabulary words. Make sure that you understand each word and know what it means and how to apply it.